This video is going to serve as a brief introduction to Dalton's law, which is another gas law that we're going to do in this chapter. So Dalton, who is the extremely awesome looking man to the left, came up with this law that's down here. And it seems really obvious, but it wasn't at the time. Cut him some slack. So it's P total is the sum of what are called partial pressures. So partial pressures occur when you've got like a beaker, or actually it would be a closed container, right? And you've got all kinds of molecules running around in here. Let's say those are nitrogen molecules, and then these ones can be hydrogens. What I can do if I want to get the total pressure is I can say the partial pressure of hydrogen plus the partial pressure of nitrogen is going to equal the total. And that's because all of the collisions that are occurring, it's going to be the sum of the total collisions. So if we look at this example, this is a nice little example of Dalton's law. In the green container, you've got 4 molecules, atoms, whatever these are, running around making collisions. It tells you the pressure is 1 atm, the volume is 2 liters. And if you look, the volume is held constant across all 3. What would the pressure be in the blue container? And now what would the pressure be in the red container? So what we can do is we can take the containers, and if we combine those, again, what we're going to do is we're going to take all the collisions that were made by those 4, and those 2. If we added up the partial pressures of green, blue, so pressure of green plus the pressure of blue plus the pressure of red, what's the total pressure in the container? Another application of Dalton's law is when we are collecting gases. So it's really hard to isolate a gas from a chemical reaction. So what we try to do is like make it run through this tube here. And if we fill this test tube completely with water, we can get the gas to displace some of the water, which is awesome. The only problem with that is that some of this water, you guys know that water can evaporate, right? Some of this water, a very small amount, is going to be left over in the test tube. So that's no good. So if we want to get just the pressure of the gas in the container, the dry gas it's called, what we're going to have to do is we're going to have to take the total pressure. And we're going to have to subtract out the pressure due to the water vapor. Okay, so finding the water vapor pressure is actually really easy. There's a table in the back of your textbook that has it, and you'll be given all of these values for any problems that you do on a test. Just note that you're going to look up the temperature in one column, and in this table, they actually give you 2 different pressures. So they've converted it to millimeters of mercury and kilopascals for you, which is kind of nice. Just make sure that you pick the right one, or if you need ATM, just convert it. So here's a problem. Hydrogen gas is generated and a total volume of gas is 35 mils is collected over water. First thing you should be paying attention to is the fact that this says over water, okay? So the temperature of the experiment is 22 and the pressure is 100.8. Solve for the pressure of the dry gas. I will leave you to this one. This is the last problem that I have here. Hydrogen gas is generated and a total volume of 20 mils is collected over water. Again, if you have a highlighter, it's worth it to bring it to the test so that you highlight that. Everybody forgets that. The temperature of the experiment is 24 and the pressure is 101.5 kilopascals. Solve for the volume of the dry gas at STP.